right, so those are your key characteristics. We've talked about transformations before. I just want to quickly review with you those transformation things and how those apply to quadratics. Okay, so transformations. All right, so the first thing that we're going to review is what happens when we change the a value. So if I have f of x equals a times x squared. So if I look at that a value, what happens to the graph? So just a couple of reminders is that it reflects actually I should say it reflects over the x-axis if the a value is negative. Okay, that tells you your opening direction, right? So if it's positive, it opens up because that's the way x squared opens. And then if it reflects over the x-axis, it's now opening down. And so if it's negative, you know that your a value is negative. Okay, so that's your reflection piece. And then we had stretches and compressions. So remember that if I ignore the negative in front and I look at just the number, so we can call that the absolute value. If that number is bigger than 1, then it's a stretch. So it stretches the graph. And then if that number is between 0 and 1, so it's a fraction less than 1, right? That's a compression. Okay. And then, so just looking at a couple of graphs, I just kind of want to remind you what happens graphically. So if I have my x squared graph, so 1, 1, 2, I'm up here 4. So this is y equals x squared. If I hit the right buttons. If I want to look at y equals 2x squared, right? We know that that's going to be a stretch by 2. So I'm multiplying everything by 2. So 0, 0 is going to stay the same. But here at 1, 1, I'm going to be up at 1, 2. Right? And then I'd be way up here at 4, or at 2, 8 rather. And so it's going to stretch up. It's like pulling a balloon upward. Right. And so if I compare those graphs, the graph is skinnier, right? It gets taller faster. So it's skinnier, it's taller. Those are a couple ways to kind of describe that. Okay. And then if I look at, let's do y equals 1/2 x squared. So instead of being at 1, I'll be at 1/2. And instead of being at 4, I'll be at 2. We can kind of see what's happening. When we do that, then I'll still be at 0, 0. Right. And so remember we looked at these when we looked at transformations before break. Right. if I compare the red graph, which is y equals 1/2 x squared, to the black one, which is the original parent function, notice it's wider, right? So the graph is wider. And maybe even like shorter or fatter. We'll call it shorter. Except that that does not look like shorter. Okay. All right, and so that's how the graphs differ. So remember, and this will kind of help you when you're doing one of your assignment pieces, that when you're looking at the a values, or you're looking at how they affect the graph, that if it gets skinnier, then it's a stretch. That means your a value is bigger than 1. And if it gets wider and it looks like it's being pushed downward, that's a compression, and your a value is a fraction between 0 and 1. Okay. And then the other transformations that we looked at were translations, right? There are two. There's horizontal and there's vertical. Okay. The horizontal ones are the ones that move it left or right. Remember that we had a rule that said that x's are deceptive, right? Our x's lie to they, so we have to remember that. So if I have y equals x minus h squared, okay, it's moving. If that's subtracted, if that's minus, that's moving to the right h units. Okay, if it's added, it's moving left. Okay, and so again, it goes opposite the way that we think it does. Right. And so since it moves the graph, it's going to move your vertex, right? And so your vertex gets moved also when we do that, okay? And so then when we do vertical, remember it's pretty straightforward. So it's x squared plus some number that's going up that amount, and if it's x squared minus some number, it's going down that amount, okay? And again, that's also going to change your vertex. So if we look at them together, if I have y equals x minus h squared plus k, that's going to move your vertex h units and your to the left or right, and then k units up or down, and so your vertex will be h, okay? And remember that that sign will always change. So if it's minus, it'll be positive, and if it's positive, it'll be negative. So for example, I had y equals x minus 3 squared plus 5, the vertex is going to be positive 3, positive 5, okay? If I had some stretch or compression out front, that is not going to affect the vertex at all, like its location. So if I have